Welcome you all for this section. Myself Mrs.S.Sivaranjani, Assistant Professor, M. Kumarasamy College of Engineering. Today we are going to discuss about Quine-Mc method. Before going to discuss about the Quine-Mc method, we must know about minimization technique. What is minimization technique? Minimization technique is a digital electronics will help you to simplify and optimize the logical expression. Actually, the end users always expect the product in the compact form. So minimization techniques is doing a very big role in digital electronics. So minimization technique will help you to minimize the logical expressions, truth tables and logic circuits, so that what we can do is we can minimize the number of components as well as we can improve the overall efficiency. So minimization techniques is overall is helping in digital electronics, and it's used to reduce the complexity and minimize the number of components, and so that we can improve the overall efficiency. So minimization technique, what are the key types of minimization techniques? Boolean algebra and Karnaugh maps and Quine-Mc method. Boolean algebra. Boolean algebra, it says that in this algebraic we are using rules and regulations. What are the rules and regulations we are using to simplify the logical expression? Commutative, associative and distribution. So here human interruption is high. Why? Because few people will use commutative, or few people will use your distribution laws, or some people will use your associative. The thing is that we can simplify the expression by using this rules and regulation, but all the peoples won't get unique expression. Then next we Karnaugh map. Karnaugh map is nothing but K maps. We can say that K map also. This is your graphical tool for simplifying the truth tables. From the truth table expression we can minimize the logic expression. By the way, we can develop the logic diagrams by using the basic gates. Here also, for grouping the ones values or zeros value, lot of human interruption is high, but here we can do the systematic manner. So here we can get unique answers, or may not get unique answers. When goes with your Quine-Mc algorithm, here in these algorithms, first we have to use the prime. First we have to find the prime implicants, and then we are going to minimize the Boolean expressions systematically. Okay. So Quine-Mc algorithm is a unique one to get the unique answers, so that we can systemize this Quine-Mc algorithm. So next we are going to see Quine-Mc procedures. We are going to see Quine-Mc first step. What is the first step? We have to list all the minterms in the binary forms. Then second step, we have to arrange the minterms according to the number of ones available in the minterms. Then third terms, we have to compare the each binary number with every term in the adjacent next higher category. While comparing the binary form with next higher category, if they differ only by one position, there we have to put a check mark and copy the term in the next column with the dash in the position where it's differed. So then next we have to apply the same process described in the step 3 for the resultant column, and we have to continue the same process until single pass through cycle yields, and we have to finalize that there is no further elimination of literals. Once there is no further elimination of literals find out, we have to list all the prime implicants. We have to list all the prime implicants, and the final step we have to select the minimum number of prime implicants which must cover all the min terms. So we are going to do the 6 steps. First we are writing the binary forms, and second step we have to write the min terms according to the number of ones. Then next we have to compare the binary number with every term in the adjacent next higher order. If you find only one position is differing, we have to put a check mark, and where the position is changing, there we have to put dash. At the same time we have to write it in the next column. Then same process we have to apply, then until no further elimination of literals. Next we have to list out all the prime implicants, and we have to select the minimum number of prime implicants which must cover all the minterms. So next we will see one example problem. The problem is we have to find the we have to simplify the Boolean expressions f of w comma x comma y comma z equal to summation of 5 comma 7 comma 9 comma 11 comma 13 comma 15. First step, we have to list the minterms by the number of ones it contains. First step, what we have to do, we have to list the minterms by the number of ones it contains. So for 5, how you will write the binary terms? 0 1 0 1. Then next 9, we have to write 1 0 0 1. Then here how many ones are available? 2 ones are available. In 5 we have 2 number of ones, and in 9 we have 2 number of ones. Next we have to write 7. In for this 7, the binary form is 0 1 1 1. For 11, 1 0 1 1. For 13, 1 1 0 1. Here if you are comparing that 7 11 13, all the binary forms will consider 3 ones, that comes under another group. Then next we are writing 15. In 15 we will have number of ones is 4. So as per the first step, depends upon the number of ones we are making into the group. So 5 and 9 contains 2 number of ones, and 7 11 13 is contains 3 number of ones, and 15 is having 4 number of ones. Then next we have to compare. Next step we have to compare 5 and 7. Okay, 5 and 7 we have to compare. When we are comparing 5 and 7, first position 5 you will have 0, and 7 you will have a 0. If you are going with your 5, your second position value is 1, and 7 second position value is 1. In 5 binary representation, the third position is 0, and 7th the third position is 1. Here we are differing. So 0 in 5th third position is 0, and 7 in third position is 1. So here differing. The next bit also we have to check. In 5, fourth position is 1, in 7th position is 1. So here third position is changing. So 5 comma 7. So for the next step we have to write 0 1 dash 1. Okay. Then next we have to compare 5 comma 11. In 5 comma 11, 5 in first position we have 0, and 11 we have the first position is 1. So first position itself the bit is changing. So next position also we have to check. 1 0 we have to check, there is also change. So this is not comes under our steps. So we have to check another term. So we are going with your 5 comma 13. When you are going with your 5 comma 13, 5 first position is 0, and 13th first position bit is 1. So here 1 bit is changing, and 5 in second position is 1, and 13 the second position is 1 is same, and 5 the third position is 0, and 13th third position is 0, and 5 first position is 1, and fourth position is 1. So here first position itself changing, the remaining second, third, fourth position is not changing. So we have to consider 5 comma 13. So while writing we have to write dash 1 0 1. Next we have to compare 9 and 7. When you are comparing 9 and 7, first position, second position, and third position are changing. So we should not take this as a consideration. Next we have to go with your 9 and 11. 9 and 11, what is that? 1 0 and 0. Here third position is changing. So while writing, we have to write 1 0 dash 1. 1 0 dash 1. Next we have to check 9 comma 13. If you are 9 comma 13, if you are checking, the second position is changing, so we have to write 1 dash 0 1. Likewise, we have to compare 7 and 15. When you are comparing 7 and 15, here the first position is changing, so dash 1 1 dash 1 1. Then next you have to compare 11 comma 15. When you are comparing 11 comma 15, the second position is changing, so 1 dash 1 1. Then next we have to check with your 13 comma 15. We have to check with your 13 comma 15. So when you are checking with your 13 comma 15, what is that? We'll have here 1 1 and third position is changing, so 1 1 dash 1. Okay, so next we have to check of all the elements are covered, and then next we have to go for next step. Okay, next step we have to check with your 5 comma 7 and 7 comma 15. If you are where you will have a third bit position is dash. If you are comparing with that, we can easily identify in which position the bit is changing. So if you are comparing third position, so 5 comma 7 and 13 comma 15, you can check. If you are going with your 5 comma 7 and 13 comma 15, what will happen? 0, first position is changing, dash 1 dash 1. So while writing, you have to write 5 comma 7 comma 13 comma 15. And then next you have to check with your 5 comma 13. 5 comma 13, here you will have in first position dash. So in your second grouping, you have to check which number is having first position dash. So 7 comma 15 is having first position dash. So 5 comma 13 and 7 comma 15, here third position is changing, so 5 comma 13 7 comma 15 dash 1 dash 1. 5 comma 13 7 comma 15. Then next you have to go with your 9 comma 11. 9 comma 11 is changing into the third position. So in this in the next group, which position which number values have third position dash. So if you are going with your 9 comma 11 and 13 comma 15, your second position is changing, so 1 dash dash 1. 9 comma 11 and 13 comma 15. So next you have to check with your 9 comma 13. In your 9 comma 13, your second position is changing. So in this next group, we have to find in the second position we are having dash, so that we can compare 9 comma 13 and 11 comma 15. So 9 comma 13, 11 comma 15, 1 dash, then third position is changing, dash 1. In this step 3, we have finished step 2, and next we are going for step 3. In first row we are having 5 comma 7 comma 13 comma 15. Okay, then next 5 comma 13 comma 7 comma 15. Both the terms are similar, and next third row 9 comma 11 comma 13 comma 15 and 9 comma 13 comma 11 comma 15. Both the terms are same. So the next, to find your prime implicants, we can write only one time, that is enough. Okay, so next we are going to find your essential prime implicants, that is 5 comma 7 comma 13 comma 15, and covered min terms are 9 comma 13 comma 11 comma 15. So for your min terms, we have to put dot or cross. Okay, so 5 7 13 15. Then next 9 13 and 11 15. Then next first we have to press your, first you can put your cross or dot for the corresponding min terms. In your first row we have 5 comma 7 comma 13 comma 15. In this from the corresponding minterms we have to put cross, or we can put your dot. As per your convenient, you can put your cross or dot. Then we have to circle the cross which is having a which is available in your single column. Okay, so 5, in this 5, in the single column we have only one cross only. There is no other cross in the second row. So if you are comparing this 5 mean term, in the single column we have only one cross. If you are going with a 7 also, we have only one cross in the 7th min term column. If you are going with your 9, in this 9 also we have only one single cross in the 9th column, 9th min term column. And if you are going with your cross with your 11th min term, there also we have only one single cross in the 11th min term column. So that which are the columns is having single if you are going with your 5th min term column, there we have only one single cross. So for that we have to put circle. So this is a circle as in a column singularly. So next we have to mark all the min terms, so that we have to consider both the prime implicants. So cross dash 1 dash 1. So this is 5, 7, 13, 15. Here what are the values we have? Alphabetic values W, X, Y, Z. Where 1 is present, that term alone we have to take X dot Z, then plus W dot Z. Here what is the common term? Z is common term, so we are taking out. So X plus W into Z. Prime implicant is dash 1 dash 1. So what are the alphabets we have used to represent our prime implicant is, in the given problem statement, f of W, X, Y, Z. So W we have dash, so we should not take. X we have only 1, and Y we have dash, and Z 1. So X dot Z, the next term 1 dash dash 1. So what is it? W and Z will have a ones. So for that we have to W dot Z. So here we have to take common out as Z, X plus W into Z. This is the final answer for your Quine-Mc method, and this is the essential prime implicants also. Next we will go and see with your don't care condition. First we as usual, as per the step, we have to divide into the number of ones. We have to divide the min terms. First I am listing out the min term values. As we all know that for 0, 0, 0, here also we have used f of W, X, Y, Z. So 4 min terms we have, so 4 binary representation we have to use, 0, 0, and 3, 0, 0, 1, and 5, 0, 1, 0, 1, for 6, 0, 1, 1, 0, and for 7, 0, 1, 1, and 10. This all the basic we know how to write your binary values for the reference. And don't care also we have to write 2, 9, 15. For all those things also we have to write your binary representations. Then number of ones available, we have to make it as a function into a group. For 0 we doesn't have a number of ones, 1, so 0 that comes under one group, and 2 will have only 1, 1, so G1, 0, 0, 1, 0, and then next G2. In 3 we have 2 number of ones, and 5 we have 2 number of ones, and 6 we have 2 number of ones, and 9 we have 2 number of ones, and 10 we have 2 number of ones, and 12 we have 2 number of ones, and 7 we have 3 number of ones, and 13 we have 3 number of ones, and 15 we have 4 number of ones. Okay, Then next we have to check 0 and 2. As usual, you check with your 0 and 2. What is that? In third position, the bit is changing. We can make it as dash or don't care. So 0, 0, dash and 0. The next you check with your 2, 3. If you are going with your 2, 3, here fourth position is changing. We can put your 0, 0, 1 dash. Likewise, we have to make it as a group. So G1, what are the groups we have? 2, 3 and 2, 6 and 2, 10. Here only one bit changing. Then comes to your G2 group, 3, 7 and 5, 7 and 6, 7, 5, 13, 9, 13 and 12, 13. If you are going with your 3, 7, first bit position is not changing. The second bit position alone changing, 0, dash, 1, 1. We can put don't care or dash. Normally we will use to follow dash. And then 5, 7. 5, 7, 0, 1, dash, 1. Then next you have to compare with your 6, 7. 6, 7, 0, 1, 1, dash. Likewise, if you are comparing with your 12, 13, 1, 1, 0, last position is changing. Likewise, we have to compare your 7, 15. 7, 15. Here first position is changing. So dash 1, 1. If you are going with your 13, 15, there also your third bit position is changing. So 1, 1, dash 1. So as usual, next we have to compare 0, 2 with 2, 3. If you are going like this, in 0, 2 we have in third position we have dash, so that if you are comparing with your 5, 7, 0, 2, if you are comparing with your 5, 7, what will happen? 0, first bit position is changing and fourth bit position also changing, so we could not able to consider this one. So 0, 2 is not mapping with any one, so that is what we are keeping as like it is. Then next we are going with your 2, 3 and 2, 3 in fourth position we have dash. So next group we have to check which is having the dash in fourth position. So 6, 7 is having the fourth position dash. So 2, 3 and 6, 7. So 0 and second bit is 0 dash. Second bit alone changing. So 0 dash and 1D. So if you are comparing with your 2, 3 and 6, 7, 0 dash 1 dash. Likewise, we have to compare 2, 6 and 3, 7. 2, 6 and 3, 7. Why we are choosing 2, 6 and 3, 7? 2, 6 in second bit we have dash and 3, 7 also we have second bit is dash. So if you are comparing with your 2, 6 and 3, 7, 0 dash 1, 1 and 0 and 1, 1. So last bit is changing, so we are taking as a 0 dash 1 dash. Likewise, we have to compare all the terms. Which are the terms are grouping? For the terms alone we are putting your tick mark. So groups are 2, 3, 6, 7 and 2, 6, 3, 7 and 5, 7, 13, 15. So which are the, so we are going for the final step, repeat step. We have to do until no more merging is possible. So 0, 2 and 2, 3, 6, 7 and 2, 10 and 5, 13, 15, 9, 13 and 12, 13. This is we are repeating this step. So here we are writing no more merging is possible. What are the terms are not merging with another groups? All the terms are we are listing out here. So these are the terms we couldn't able to do another more merging. So final step, all the prime implicants are listed out here. Here we have to check in which column we have a single dot. In 0 we have a, in 0th column we have a single dot, so that we have to make a circle for the 0, 2 rows fully. Likewise, we have to check another column. If you are going with your third minterm column, we have a only one single dot. In that row we have to mark all the dots. Likewise, if you are going with your 5 also we have a only single dot in this column. That row we have to full make it as a circle. Likewise, we have to mark, so we have to make it as a we have to like this rules we have to follow, and we have to make all the circles. Here all the minterms are covering, so we have to consider all the minterms. Here 5, 7, 13, 15 we will have only dash 1 dash 1, that is we have x, z. In second term we have w bar and y, and 0, 2 we have 0, 0 dash 0. Here we have to write w bar, x bar and z. If we have a 1 we have to take w. If we have a 0 we have make it as a w bar. Likewise, if we are going with a 2, 10 x bar, y, z bar. Likewise, we have to write all the minterms, and finally we have to write the final answer. F w of x, y, z equal to x of z plus w bar y plus w bar x bar z bar plus x bar y z bar plus w y bar z plus w x bar y bar. This is one kind of example. Then here all the minterms are including, so we have to consider all the minterms. Here the final result is f equal to w z bar plus y.